Okay, we're going to begin section 5.1, graphing linear equations. Our objectives in this section are going to be to put a linear equation in two variables into slope-intercept form, so using skills from chapter 4.6, finding the x and y intercepts, finding solutions to linear equations in two variables algebraically, and Lehman will also discuss the difference between equations in one variable and two variables. I will not be discussing this. I will leave that strictly for his book. Pardon me. So the first thing that we want to do is we want to talk about a linear equation in two variables and what exactly that means. A linear equation in two variables in general form, or sometimes called standard form, whose solutions are ordered pairs. This is a straight line when we represent it visually, and it looks like some a times our variable x plus some b times our variable y is equal to some constant c. And a, b, and c are all constants, which are elements of the real numbers. X and y are variables, and x and y can't be both equal to 0, so the a can't equal b, which can't equal 0 at the same time. Solving for y from the general linear form is going to put us into slope-intercept form. And so in order to make that happen, what we want to do is we want to add the opposite of the x term to both sides, moving it to the side with the constant. And then we want to multiply all terms by the reciprocal of the numeric coefficient of the y term. And that means that we're going to get every single term divided by that. So we're going to take a look at an example here. We're going to look at negative 3x plus 1/2 y is equal to negative 2. And our goal in this is to put it in slope-intercept form. Oops, I forgot the y there. And now we're going to get this negative 3x away from the y term, so we're going to add its opposite to both sides. Make sure that when you're doing this that you're not combining unlike terms like we discussed in section 4.6. So when we add, we're going to get a 1/2 y on the left-hand side, and that's going to be equal to 3x, and then you can write it as plus a negative 2 or just minus a 2. It's totally up to you. Now the last thing that we need to do is get the numeric coefficient of the y away, so we're going to multiply by the reciprocal of 1/2, the reciprocal of 1/2, which is going to give us 2, and not just one term on this side, but both terms. And we don't want to use the distributive property. We kind of want to put it as in terms of multiply everything by that reciprocal of numeric coefficient. So finally we get that y is equal to 3 times 2. Don't confuse my notation there. That does mean 3 times. I just have a little space. And then 2 times 2, which is 4. Those are not meant to be exponents. And now that's putting it in slope-intercept form. Now, of course, from slope-intercept form, remember that the numeric coefficient of y is our slope, and the y-intercept is our constant, and we usually put y-intercepts in this form here. Now, since how I'm doing this, don't forget that you could graph this, right? And we could graph it based upon the slope and the y-intercept that we were totally used to before. That is one method of doing it. We're actually going to learn another method of graphing lines in this section because we now have all the skills that we can put together in order to do that. But this slope-intercept form is still the best way to graph a line. Alrighty, now we're going to go ahead and we're going to have a problem where we're going to solve for y again. And in this equation, this example number 2 here, we don't have as difficult of a time of doing that. So why don't you guys go ahead and write down example number 2. 3y is equal to 6x minus 4, and 2x plus 3y is equal to 9. So try to solve those on your own and then come back in the next lecture and we'll see how you did on that one.